Our next speaker is a platinum member over at OCP, Microsoft. They're also one of our board members. Mr. Danny Tang is the CTO for Microsoft Taiwan, 24 years of experience. His charter is to basically enable digital transformation in the industry and heavily, as you probably guessed, invested in IoT and AI. So he's going to be talking about IoT and AI. Come on up here, Mr. Tang.
Yep. Good morning.
Still morning?
I'm Danny Ting, Microsoft Taiwan CTO. And it's my pleasure to be here. And in the next 30 minutes, I would like to give you a quick update about the Microsoft Global Data Center scale, our offering, and our market status. And then I would like to give you an update regarding the Microsoft journey with the OCP community and several ongoing projects. So let's start with the Microsoft Global Data Center scale. And as you can see, this Azure data center spans for around 54 regions globally. It's more than any other cloud vendor. And you can, our data center provides the flexibility, so you can deploy your application closer to your user, no matter where they are. And you can see the global infrastructure here. So it also provides the scalability, redundancy, and the data residency for your needed. And in order to manage the global scale, and Microsoft need to have the innovation on design, build, operation, and manage our data center infrastructure globally. So in terms of innovation, the first thing we would like to think about how can we have our own hardware design. So that's we need to support the global cloud growth, new services innovation with efficient and cost-effective way. So that's why we joined the OCP community and work with the leverage the open source, the collaboration with the member to design the next generation rack level hardware solution. So that's a Project Olympus. So I will elaborate more detail later on. So not only the hardware data center innovation, but also we need to have the new way to manage an operation in our data center. So you can see we leverage Azure services to unlock the operational telemetry and sensor data to do the analytics. So we fully utilize our Azure IoT and machine learning to get the data from the power and cooling system to do some remote monitoring, health check, and also we leverage our AI services to manage control and to do the maintenance job. So that's improve our reliability and efficiency. So that's regarding the operation part. In terms of the global network, so you can see the global infrastructure Microsoft have, and we are running one of the largest network in the world. So we invest a lot, significant investment on several areas. You can see the network connectivity here. And later I will show you about the Sonic project and how can we leverage that to provide the reliable network services in our data center. So next, you can see the software part, services on top of our Azure. And yeah, some people say Azure or, okay. So Microsoft embrace open source. So you can see, you can choose any kind of a tool, application, and infrastructure, operating system you like. So we provide any kind of infrastructure as a services, database services, management, application framework, and so on. And maybe you don't know that, but I can share you with about right now, over 50% of the server on the Azure is running Linux. And on the other hand, Microsoft is also the #1 open source contributor in the world every year. And not only that, we also have a lot of services. We call it platform as a services, over 100 different kind of services. For example, IoT, AI, security, management, and so on, to support our customer can build their solution in a very short period of time. So in terms of the market situation, so let's just give you a reference. Right now, over 95% of a Fortune 500 customer is using Microsoft Azure to build their solution on top of that globally. So I mentioned that we invest a lot and a lot of innovation. So right now, our customer can get some benefit regarding the best-in-class performance. So I won't go through the detail, but you can see here. And there's some specific skill. We support the SAP HANA to support 960 CPU and 24 terabyte RAM. So it's a huge database. So that's the benefit we want to share with our customer. So that's the first part you can see. The second, I would like to share with you about the Microsoft journey with the OCP. And Microsoft joined OCP since 2014. And since that time, we contribute a lot of area. For example, rack design and security, networking, SSD. And in this year, OCP Summit in March, we also have the new announcement to focus on data, because you know data is the heart of the digital transformation. So we need to resolve the challenge the industry facing. So this is the Project Olympus. And we share with the OCP in late of the 2016. And we already contribute over 20-something specification around that. And you can see the rack system, and we select a 19 inches rack. And we also have the 40A and 42U readily available. And also we have the individual 3-phase power supply to reduce the cost. And we also have the mixture of the compute and storage to make sure we provide the flexibility and agility. And you can see the motherboard side. We did support universal motherboard specification, include Intel motherboard and also AMD EPYC specification. So that's a quick update about the Project Olympus, but it's still ongoing. And the other two initiatives which Microsoft contribute in the past 2 years, I would like to highlight the status here. The first one is a Project Cerberus. Project Cerberus is we open source in 2017 November, and it's a hardware root of trust. And so in terms of a hardware root of trust, you can see originally is more focused on BMC. And right now, Microsoft work with the partner, the OCP member, to extend the specification and support the master-slave architecture. So we expand from the server specification to the peripheral side. So right now, the root of trust is focused on the protect the supply chain attack or runtime attack. Now they extend to the network network card, SSD, or GPU accelerator things. So that's Project Cerberus status. And the other update is all the Project Olympus motherboard now have a Cerberus capability right now. So you can benefit to the from this feature to support the security. And the other thing, the other initiative which we announced last year is Project Denali. And Project Denali in the past year is around 15 companies participate. And we work on the first release of the specification. And you can see there's a lot of interesting scenario, but you can see the usage model, not just on cloud. A lot of the scenario is outside cloud. So you can see like the enterprise array, IoT applications, something like that. And also you can take a look that it's a prototype of the Microsoft Denali SSD. And basically within it can save cost of up to 70%. So right now we already have the plan on that. So next I would like to share with you about the data. It's a key announcement this year. So everybody think about the huge data will be generated by everybody and every company in the world. And right now we talk about the 5G, IoT. So more and more data coming up. So where is the data coming from? You can take a look at the IDC report. And IDC report, there's a very good reference. You can see there's almost the data generated at the endpoint. So there's 10 different endpoint, different scenario. You can take a look. Cell phone and IoT device, such as that. And all the data will be sent to the edge, collect by edge and have some preprocess at the edge side. The three area like the cell tower, gateway, and branch office. And finally, it may be sent to the large data center, a private data center or public cloud for the analyze, store, or even archive. So that's IDC provide the reference here. And they also have some projection for the data growth. So you can see there's a counter here. So far, it's 33 zettabyte this year. And then focused until the 2025, there was a huge number, 175 zettabyte. So zettabyte is 1 followed by 21 zero, you can see. So there's a huge data. If you have this kind of data and you write to the DVD, so the DVD deck will be circle the Earth around 200 times. So that's incredible. And another is IDC provide a storage capacity growth projection. And no matter what kind of storage or technology you use, the industry is difficult to keep up with the growth rate, very high growth rate. So there's only two ways you would need to think about how to deal with the situation. The first one, maybe it's you cannot keep all the data, so you need to drop it. For example, you got the data and you analyze them and keep the analyzed result and drop the data. This is number one. The other option is if you can find an efficient way for the data storage and management. That's the solution we want to achieve. So that's a project, we call it Project Zipline. We announced in the OCP Summit this March. So we would like to find out the efficient way of managing data and implement in the hardware and software together. So the Project Zipline, you can see it's a target to the two different data set. It's legacy and modern. Legacy data set is kind of a application log or system log. And the modern data set is it's like the new IoT and telemetry data, sensor data. So we should target those kind of data set and the scenario from the edge to cloud. The second thing is about how can we implementation. It's not just compression. By the way, the project Zipline, the core concept, the key is compression standard. So the Zipline is not just focus on compression standard. We need to think about how can we implement software implementation on the algorithm and also hardware part. So second. The third key thing about the Zipline is compression without compromise. So if you look at the scenario we talk about, you need to think about from 3 different angles. The first one is it need to provide a very high compression ratio. And you also need a high bandwidth to process to get the data stream. And also you need extremely low latency to get the data and provide the result. So that's a Zipline compression game. And Microsoft, we leverage our internal data. This data from our data center. This application log, system log, and IoT telemetry data. And you can see there's a very high compression games from 96% to 92%. And it's better, around 20% better compression rate, better than the average current compression algorithm in the market. So we just announced the open sourcing the project Zipline. The first thing we open is compression algorithm. It's a compression new standard, and algorithm and specification, the first aspect. The second aspect is hardware architecture specification. If you want to implement in hardware, you need to get the hardware specification and pseudocode, or even microarchitecture diagram like this. So we also provide that. The third part is most important, and we are very exciting about, is this is the first time in OCP history, and Microsoft provide the RTL source and test suite. RTL is a registered transfer language. It's a silicon design language. So that will empower our partner ecosystem can design and fine-tune the algorithm to support the different usage model. For example, in edge side, you maybe more care about the power than the performance, but in the cloud, it's a different story. So you can see the project Zipline, the usage model from the different, for example, storage, SSD, IoT, edge side, edge computing, a lot of different scenario. And you can see we need the ecosystem to support that. So right now you can see the whole partner ecosystem support this project. And from the top of this diagram is a CPU vendor, most there. And the bottom side is a EDA tool, also support. In the middle, networking and the storage vendor. So next, I would like to share with you a quick video about how our partner ecosystem mentioned about the benefit they got regarding the project Zipline.
Azure has been growing exponentially worldwide. Every single bit of efficiency matters. They've estimated that there's about 33 zettabytes of data in the data sphere today. And as far as data that's stored, they estimate that about 50% is going to be stored in hyperscale public clouds by the year 2025. As the cloud scales, as data processing becomes more critical part of our everyday lives and everything we do, the ability to process that efficiently is more important than ever.
innovation in our compression algorithms have allowed us to better utilize our storage platforms and capacity.
We've been able to get higher compression ratios, more throughput, and lower latency than the other algorithms.
Enhancements like this can lead to direct customer benefit. The potential for cost savings, for instance.
Broadcom, partnering with Microsoft and others in the OCP community, allows us to get insights that help us align our products with industry needs.
Access to petabytes or exabytes of capacity in a cost-effective way could enable new scenarios for our customers.
When you think about the overall data-centric transformation that's happening, it's critical that we enable the industry with the right solutions to move, store, and process a wide variety of data across a wide variety of use cases.
You can't say that innovation is all coming from one place. It's going to come from everywhere. Open source ecosystems are fueled by contributions, the collaboration across the community. We take the designs for our servers in our data center and contribute them to OCP. This contribution is unique because it's the first time anybody's contributed RTL. Hardware manufacturers can take that design and go directly and produce chips that they can sell to customers. The whole ecosystem can take advantage of our innovations, and we can also take advantage of the contributions they make to the designs.
Open standards are really vital for the entire industry. Intel and Microsoft have had a deep collaboration that's really been cloud focused. We're really excited about Microsoft taking a leadership position here and really contributing their overall compression format to the open source community.
The value of XP10 to OCP is primarily in two areas, interop and cost. Lowering storage cost is good for everyone. Having an open source standard allows the customers to compress their data in one data center and then transport it and be able to decompress it anywhere else.
Having a company like Microsoft, which is seen as a leader in the industry, can create a center of gravity. With us contributing designs, especially something like RTL, as setting a precedent, hopefully others will follow that precedent, and we look forward to seeing the kind of interesting designs that are going to come back from other participants.
Okay, so after we announced the project Zipline, we just announced project Corsica this month. In May. And this is the ASIC implementation with the Zipline technology. So you can see the picture here is a special design ASIC designed by Microsoft and our partner Broadcom. And it fully leveraged the compression without compromise concept, and we pack the encryption and compression and also data authentication together. So you can see it's truly a significant offload from the, you can see here is a CPU, offload the load from CPU to the dedicated chipset. And the throughput, we improve a lot to the 100 gigabyte per second. So it's around 15 to 25 times faster than CPU. So that's about the project Zipline and Corsica. And next, I would like to share with you about the networking part. And as I mentioned earlier, Microsoft is running the largest network in the world, but however, it's quite challenging to manage and operate. And the key challenge here is how can we provide the reliable network and make sure that its availability is one thing. The other thing is how can we have the innovation provide the new capability and new network service to our customer. So Sonic is a software for open network in the cloud. And it's a software that, open source software that run and operate on a network switch and with 4 basic principles here. So it's control, I think it's based on the open source. So control means if you are a network service provider, you can take a look at the detail and design what kind of feature you want to ship with the switch. Extensibility means that any developer can add new feature on top of that. Agility means if you want to have the more quickly develop and deploy to the network, the agility is a key. Finally, collaboration which means we work with the open source community to improve that, to make sure more reliable, more powerful. So that's a basic principle. So the Sonic concept, give you more detail about that. It's a Sonic project just start with the hardware platform. And on top of that, we're running Linux. Why Linux? Is because of Linux, a lot of people already use that, and we just want to make sure you manage the server and the SAN with the switch device here. And there's also standard here, the OCP support. It's a SI, switch abstraction interface, to help the Linux can interact with the hardware device, ASIC vendor. And on top of the Linux and the SI, there's a Sonic software component here. The key thing here is all the component has already been containerized. So which means every component can be upgrade individually, develop individually, and test individually. Or even new developer, a developer want to develop new feature, so they can easily to develop a container and deploy to the Sonic layer. And on top of that, there's a large ecosystem. It's to manage container and a lot of tool you can leverage and also integrate with your environment. So that's a Sonic. And Sonic is not the US only. It's global, so that's China. You can see CDCC, ODCC, Open Data Center Committee, and it also have the Finnish project, and encourage the white box to adopt the Sonic firmware. And you can see a lot of, like the Alibaba, Tencent also adopt this technology. And Microsoft, of course, fully commit on the Sonic side, Sonic technology. So right now, we already deployed to 44 regions, and we deploy firmware upgrade up to thousands of switch every day. And on the other hand, I think we have the easily to have the new application tool around the Sonic, which is ONE, Open Network Emulation. It helps us to test the configuration before we roll out to the production side. And moving forward, we will deploy all the Sonic to all our data center and extend to the other side, like the network management, wide area network, gateway, and so on. Last, I would like to show you this one page. It's about the Sonic project journey. From the beginning, it's about 2016. It's a basic layer 2, layer 3 routing switch. And after that, we have the networking operating system and add on more new feature to support gateway data center, and more vendor participation join this community. And we also see the key challenge here is commercial support. So the open source need to get the trust by the customer. So commercial support, enterprise support is very important. So we are glad to see the industry vendor like Appstrong and Mellanox and also Dell join to provide the enterprise level commercial support to the industry. So that's all about my presentation, and I would like to thank you for your listening. And my feeling is the open source community is super powerful. As you know, I joined Microsoft for 24 years, and I never think about this one day we embrace open source like this way. Not just the software, but also in hardware space. So I believe it can continue to support this industry to make more impactful. So welcome, everybody can join the OCP to make our life more better. Thank you.